Welcome to a summary of lesson 11.6. A summary of these notes, actually of the theorems. Typically you will explore these theorems in class and try to come up with some of those formulas. We'll summarize and do some examples. Depending on how much time we have in the school year, we are getting toward the end of the school year, it is possible that we don't have time to do all of the exploration. So using the diagram at the right, here is what we call the chord-chord theorem. I don't memorize it as 1161. We've talked about you memorizing by numbers before. This chord is separated into two pieces, AE and EC, when they intersect. When they intersect, this one's cut into two pieces, DE and EB. The pieces are not necessarily equal. They are not bisected. If one of them is bisected, then we know from a previous lesson that it can only be bisected by a radius or diameter. Neither one of these is a radius or diameter, so they are not being bisected. However, chord-chord theorem tells us that there is a relationship between them, even if they aren't the same length, even if they don't bisect each other. And that relationship is that the product of these two pieces is equal to the product of these two pieces. Let's summarize that after we look above. 10 times 2 is 20. 4 times 5 is 20. 3 times 4 is 12. And 6 times 2 is 12. Chord-chord theorem tells us that the product of the pieces on one chord equals the product of the pieces on the other chord. Product of pieces of one chord equals product of pieces of other chord. That is what chord-chord theorem says. In other words, if I split these into, I'm going to name them A, B, C, and D just to make it easier. But since AE is A, and EC is B, and DE is C, and EB is D, I would have that A times B will be equal to C times D. Those statements, or those products, will be equal. Example A, using chord-chord theorem. Find the length of each chord. I first have to pay attention to what I have in the picture because there are theorems with secants and tangent lines as well. I have a chord and I have another chord and they are intersecting. I know this piece of the chord but not this piece, and I do know both of these pieces. So using chord-chord theorem, I have that 7 times 10 will be equal to 14 times x. 7 times 10 is 70. 70 divided by 14 is 5. So now I know the length of x, or the length of this piece, is 5. Notice they did not ask for the length of the missing piece, they asked for the length of each chord. This means that GH is 14 plus 5, which is 19, and the length of FE, that I could have gotten without solving, just to add them together, is 17. I don't know the units, so I just put a U for units. In letter B, same idea. This is a chord, this is a chord, those are the two pieces. This is a chord, this is a chord, those are the two pieces. So I have that 30 equals 8x. 30 divided by 8 is 3.75. Now that I know the value of x, I can definitively say that 8 plus 3.75 is 11.75 for the length of CD, and 6 plus 5 is 11 for the length of AB. So even though the chords aren't equal, and even though they don't bisect each other, the product of the pieces of one chord equals the product of the pieces of the other chord. In this next problem, we actually have, archaeologists have, it's an application problem, and it actually draws on a previous theorem as well. Archaeologists have a shard of a plate with given measurements. They want to find the diameter of the plate. so they can know how much food will fit on the plate. What is the diameter? They've told me that this is 6 and that this is 3. Well, there's a couple ways to solve this, but we want this to be a diameter. If that's going to be a diameter, that makes AB a chord. And what does the diameter always do to the chord? Well, if it's perpendicular to it, and we're making it so that it will bisect that chord. That means that this is also 6 inches. So this is a chord and this is a chord. The diameter itself is a chord. Part of the diameter is 3, part of the diameter is x. So for our diameter and our chord, remember diameter is a chord. For our diameter we have the pieces 3 and x. I'm going to multiply those together. For the chord that has been bisected, we have 6 by 6. So we have that 3x equals 36, meaning that x is 12. 12 inches was the diameter of this plate before it was destroyed. Summary of the next theorem. Oh, no, there's one more problem. I'm going to ask you to give that one a try, and if you haven't already, then I will summarize it. Again, if you read the problem, we have a full diameter. Well, actually, it's not a full diameter, it's a chord. But they have shown it's been bisected, which means this is part of the diameter. I don't know the other part of the diameter. So I have 8x equals 9 times 9, 81. 81 divided by 9 is 9. On to our very next theorem. Again, if there was time in class, we took some time to explore if there was time in the curriculum. If not, we need to summarize this theorem. This theorem is the secant theorem, and it could also be done with a secant and a tangent. Secant theorem is different. Give me 1 second. I want to make sure I summarize this correctly. This one is a little trickier. It is not piece times piece. That only works for chord. This is what we call secant theorem. You have 2 secants outside of that run through the circle, and part of it's outside. So with this theorem, we actually have to do the entire secant segment times its external piece, and that will equal the same for the other one. Full secant segment times outside piece equals full, this is assuming they share a vertex. If they don't share a vertex, this doesn't work. Okay, full secant segment times outside piece equals full secant segment times outside piece. What's nice is that the formula doesn't have 2 different things. It's the same on both sides of the equation. So let me give you an example from above so that you can see that this works. The full length of this is 12. 12 is the full length, 4 is the outside piece. 12 times 4 is 48. 3 and 13 is 16. The outside piece is 3. 16 times 3 is also 48. So you can see how this theorem works. The full secant times the outside piece equals the full secant segment times the outside piece. That's secant theorem. I can see it, can't you? So we have this full length here, 9 plus 7 is 16. So we have to do dE times the outside piece. So we've got 16 times 7. That's the full piece and the outside piece. The full piece for GE will be x plus 8. The outside piece is 8. So we just have to multiply. I have 8x plus 64 equals 16 times 7, which is 112. I don't know why I wrote, this is 64. 112 minus 64 divided by 8 is 6. X equals 6. They did not ask for x, so they asked for the length of the full segment. So the full segment for this was 8 plus 6, which is 14 for GE. 9 plus 7, we already knew that DE was 16. For letter B, the full length of JG is Z plus 13. The outside piece is 13. The full length for LK is 39. The outside piece is 9. 39 by 9 is 351. This is 13Z plus 169, I think. Yep. So now I have 351 minus 169. So 13Z equals 182. Divide by 13, we'd have that Z is 14. We weren't asked to find the variable, we were asked to find the segment lengths. So JG would be 14 plus 13, or 27, and LK, we already knew, was 39. This summarizes the secant-secant theorem. The summary of our very last theorem from this section is the secant-tangent product theorem. Secant-tangent theorem. It's called secant-tangent product theorem. What we do is it's going to be like before with the secant. We need the full piece times the outside piece. Full secant times outside piece of the secant. But for the tangent, I only have one piece. So I have to square it. Equals the tangent squared. The secant, full secant times outside piece, just like before, but here it equals the tangent squared. Let's take a look at some numerical examples above. The full was 9. The outside was 4. That's 36. For the tangent, it was 6, and 6 squared is also 36. The full was 3.6 times the outside 1.6. 3.6 times 1.6 is 5.76. The tangent was 2.4. When squared, it also gives me 5.76. So we used this theorem to solve problems like this one. Here the full was 20 times the outside piece of 5 equaled x squared. So x squared is 100, meaning that x is 10. All we had to do was find x, otherwise we'd say the length of the tangent line LK is 10, and the length of the secant line is 20. For letter B, same thing. DG is the tangent, so 10 squared, the tangent line squared, equals the full piece, y plus 7, times the outside piece, 7. 7y plus 49 equals 100. 100 minus 49 is 51. Divided by 7 is going to be 51/7. Or we could give a decimal approximation if we needed to, but this would be the exact value. This concludes the summary of lesson 11.6. There are 3 theorems: secant-tangent theorem, secant-secant theorem, and chord-chord theorem. Hopefully this summary video helps you review these things. If not, you can also take a look at the HALT online book. Have a great day.